Swayam Prabha. Digital India. Educated India.
Well, in today's lecture, we'll talk about the manufacturing of coke and the related air pollution issues, and also the control of air pollution emissions from coke manufacturing. So the focus today is on coke. Okay, let's see what is the importance of the coke. As you can see, coke is a very critical, very crucial raw material for iron making and steel making. So not only all large steel plants, as you probably know, would require coke, as well as the small plants like foundries using cupola furnaces would also require the coke. So let's see what the coke really is and how it is manufactured. In fact, in all blast furnace, if you recall from your high school metallurgical processes that you have studied, for operation of the blast furnace, a pure form of the carbon is required for the reduction of iron ore, okay, and that also need to supply some kind of energy. So this reduction that is undertaken in the blast furnace is essentially because of the coke. So coke is very essential in manufacturing of steel, iron, maybe in the large plants or in the small plants. And this, the carbon, the pure carbon is called as a coke. How it is manufactured, we'll go very briefly with the process. Coke is obtained by the destructive distillation, as you can see here, and that process of destructive distillation is also called carbonization. Okay, in fact, what you see here, this off, please leave this off. The coke is obtained by destructive distillation, and that process of destructive distillation is called carbonization of selected coking coal. That's very important. The component here, selecting coking coal at high temperatures, that's about 950 to about 1050 degrees Celsius. Why I'm underlining the selected coking coal is that not all kinds of the coal can be used for the manufacturing of coke, because we need very high quality of coal with very low ash content, because we don't want ash to be present in the coke, because if we have the ash, that will interfere with the steel making and we won't be able to make good quality of steel. So it's very important that a good quality of coking coal is only used for manufacturing of coke. Then coke is basically pyrolyzed. Pyrolyzed means when you're heating something in the absence of oxygen, or almost near absence of the oxygen. The coke is pyrolyzed coal, or coal that has been heated up to 950 to 1050, that's 1050 degrees Celsius, but not burnt. We don't want to burn the coal, because out of the coal we want to produce the coke, and we only want to heat it externally. So in the process, when we are heating it, what happens to the coal, we will see in a moment. When you are heating the coal, complex organic molecules are formed. As you can see, I am trying to underline for you. Those molecules breaks to yield gases, and we will see what kind of gases. Some kind of liquid also comes out, and solid organics is also comes out in the process of carbonization. But what is left is, that is of importance to us, is non-volatile carbonaceous residue, and that is what we call that as a coke. And we will see the process of coke manufacturing a little bit in more details so that we can identify what are the sources and what is such an important issue associated with coke manufacturing that we need to discuss in this course. And what coke structurally, if you look at the coke, it is a very porous substance, okay, and the idea of having it in a porous form is to have the large surface area, so that the reaction, especially the reduction process that is going on, that effectively takes place in the blast furnace or wherever you are making the steel. Okay, let's see a picture which is more of a schematic picture, and that gives you an idea. I'll give you the idea of the dimensions a little later, but just see what it takes to make the coke. And here you are looking at the schematic picture, and then this figure is the general layout, as you can see here, of the byproduct coke oven battery. I'll explain you what is the meaning of the byproduct, but what you see here is a long housing kind of thing, and there are lots of slits as you can see here. For example, I'll just hatch a small slit here. Okay, this is what is small thing, what you see is a coke oven. So there are series of ovens, as you can see, there could be hundreds of them, as you can see in this direction, hundreds of ovens are there, and then on the top is what we call as the Larry car. Okay, and this Larry car we have the coal, and then this Larry car fills the ovens from the top into the ovens. Okay, and then you see down here, what you see are little rectangles, as you see here as I am drawing them on for you, is that's where the heating is done. The gas is burned through this area, and then this heated air or the heated gases goes up, it cooks the coal get heated up in the process, and the emissions of the gases or the complex molecules that get emitted. Once the coking operation is complete, the coke is ready, and as you can see here, coke is being pushed out, okay, and it is put into the coal car. So the idea here, again I'll repeat, is to drive out the VOCs. VOCs stand for volatile organic compounds. We don't want volatile organic compounds because we want the pure carbon. So it's best basically heat up the things, whatever the volatile, that will go away, and then provide the porous support for limestone and other fluxes in the blast furnace. It is also a fuel for the blast furnace. It acts as a reductant, removing the oxidants from the ore. So basically the coal, we are transferring coal to the coal into the carbon and using the destructive distillation. What I would do is to make a little bigger picture, show you the bigger picture, so things become more clear to you, and that picture just follows. Okay, this is a real coke oven that I am showing you just to get a feel as to how it looks like. And before going to the sources, you can see here this the person here with the mask on his face is standing on the top of the coke ovens, on the top surface of the coke oven, and somewhere here you can't see is the Larry car. I mentioned you Larry car. So in this Larry car there is a coal filled on top of this. There is a coal in the Larry car, and these are the holes, and the Larry, and then you see here the track, railway track. The Larry car moves on this track, and whichever oven, these are the different ovens, these holes are open, and Larry car sits right on top of this, and coal is put into the oven, and then the heating process goes on. So you can also see that as the coal is being charged into the oven, there are a lot of dust emissions, as you can see in this area on your screen. Okay, and this emission is a serious problem, and we'll learn why it is serious. So you can see the person who's standing, of course there's a lot of heat, temperature is very high, and also the emissions are so toxic in nature, the person has to wear the mask. Okay, and so we'll discuss the emissions and what the emissions are in terms of the toxicity, in terms of the problems it can cause to our human body. So it's just to give you a little feel, and this picture is only at the top of the battery, top of the oven, and I must specify the group of the ovens are called the batteries. So this is one single battery. This is a picture taken from the side or from the ground. Okay, you see here the Larry car was somewhere here at the top, the person was standing somewhere here, but now we have the picture which is taken from the ground. This is our ground. Okay, so these are the ovens. As you can see, this light here, this slit for example, it's a oven. Okay. Okay, and here is the at the bottom is the we call it under fire. Okay, somehow we'll see, but right now just understand that there's some heating is done, and this heat flows, the hot air flows around the oven, but not come in the contact with the oven, because we don't want to burn the coal, we just want to heat it. And something like we are cooking on the kitchen, so we don't want to burn our food, but we just want to heat our food. So the coal is being heated externally, okay, and then this whatever the under fire, it heats everything and goes out from this chimney, as you can see on this chimney. Okay, and then after some time what would happen is that once the coke is ready, coke is done, because we have to do the cooking of the coal, and at the temperature, as we said, about 950 to 1050 degrees Celsius, and then once the cooking takes normally about between 20 to 30 hours, and then what we do is that once the coke is ready, then we need to push it out. Okay, and then we will see. Okay, maybe I'll show you this picture before that. We will show the next picture. See, now what is happening is coke is ready, so it must be driven out. So you see here the coke is being I'll try to draw a picture, is being pushed from where? From the ovens. So see here the red, it is not burning, but it's a very hot thing, and then here what you see here is another car or cart, if you like, then quickly it is transferred here, and then this must be immediately be cooled, and we'll see how this is cooled in a moment. So this is what the real pictures was, just that you get an idea as to what is happening, what are the size of the machines that we are talking about. They are huge things, and it also means huge pollution. So what we would do is that show you the earlier slide. Okay, now we will talk about this specifically about the sources of the air pollution. Okay, so here what you see, now you have the clarity. Now we are seeing both the pictures from the top as well as from the side, and also the bottom portion. Okay, and the bottom portion, as you can see here, okay, is a kind of regenerator, but mostly it is, we call it under fire. Under fire means we are firing some gases to give us the heat, and that heat should be used by the ovens. And you see here inside this picture, okay, this is your coke which is being ready. Okay, so this is coke, and as you can see here, the coke, as coke gets ready, it's being pushed. You see here, this is called pushing arm, is ready, the whole thing is being pushed, takes away a lot of energy, huge machinery requirement, and you can see this whole thing is falling down onto this is called quench car. Can you see here? Quench car. Why quench car? Because we must quickly cool off the hot coke. If we don't cool off, what will happen is, it's a hot, it's open in the air, oxygen is available, and when oxygen available, things start get burning. So in fact, if you don't take it and quickly quench it, it's going to catch fire, and you can see the flames coming out, and our entire purpose of coke making will be defeated. So we must quickly, as soon as the whole thing is out, we should quickly take it to the quench tower. And then here I try to and the whole thing is like on the railway track, and then this thing is pushed quickly in this direction and taken to the quenching tower. I have drawn this picture of the quenching tower, and we'll see a little later as to what is quenching tower and what it does. But the idea of the quenching tower is to put lots of water, tons of water, which is stored on top onto this coke. because coke we need to cool that down. We don't want it to be exposed to the atmosphere so that it starts burning. Okay, so then we are in trouble, both from the pollution point of view as well as from the production point of view. So this is one part. Let's go back onto the top of the coke ovens and see what is happening. You see here the coke oven top. Okay, this is the Larry car which I showed you, and this is what we call as the charging holes. For example, this is a charging hole, this is a charging hole, this is charging hole, this is charging hole. So Larry car moves back and forth, okay, and it fits exactly onto the charging hole. Like for example, now whatever this oven is, okay, that's being charged. So here this is a hopper of Larry car which has a coal, and this is another hopper which has a coal, and it is dumping the coal inside the oven. Okay, and what happens when it is dumping the coal? Okay, when something is being dumped in a certain room, it should replace the air whatever is there. Okay, okay. So what happens once you are dumping the things? The air must come out. Okay, and where does that air goes? What you can see here is this air which is being replaced by the coke is driven out from these pipes. Okay, so this is what is a pipe which is active right now, and this all the air that is got replaced and all that emissions that take place is passed through this duct, if you like. This is the duct. Okay, this is called mains. So all the air that is got replaced, and in the process whatever is the emission that are taking place, this must go to this duct, and then all the dirty air is sucked through this duct and taken to a process which is called byproduct recovery plant. Okay, so right now we are not showing the byproduct recovery, but you can see in the title there is a byproduct recovery. So this all that emissions that takes place must go to the byproduct recovery plant. Otherwise these emissions, if we did not have this duct here and we had not done the collection of the emissions that are taking place, they would come out in the air, okay, and cause lots of problems. When we can see, you can already see we had this mains, we had the collection system, and even then the person was wearing the mask. So there were the problems. But if we had not had this mains, as you can see here, okay, the emissions will be even enormous, so that it goes to the byproduct recovery plant. Okay, having said that, and you can also see this chimney which is number 5. Okay, will come these numbers slowly. These are the emissions that are taking place from the under fire. Okay, the under fire goes heated up, and then it is coming out from the chimney at the end through this chimney. Okay, so this again the emissions takes place. So now let's look at the thing that although we having the mains, you have to put little attention, although we are having the mains, most of the pollution or most of the emission is being collected, okay, and going to where? Byproduct recovery, where we'll control this source. But in spite of having this system here, okay, there is still air pollution that takes place, and the major sources as you can see are listed as number 1, number 2, number 3, number 4 and number 5, and I would also say number 6 that we will talk in a moment. So here number 1, as you can read from here, is called the pushing emissions. See here, pushing emissions, because as you are pushing the things, whatever are the vapor forms or vapor compounds which are there, they are getting emitted from the sides. Okay, that also, because earlier everything was closed, now it is open because we are taking the things out. So all these emissions takes place. The second thing what you can see here is the charging emissions. Okay, the charging emissions is again when you are charging the coal, and who is charging the coal? The Larry car is charging coal. When the coal is being charged here, okay, as it replaces the space underneath the space or the air, the emissions takes place. Okay, that is emission number 2. Okay, and this emission is very significant emission. In fact, the picture which I showed you, the person wearing the mask, he was trying to be far away from the Larry cart so that he is not exposed to the air pollution problem. So here the emission takes place as the coal is being fed into the oven. Let's look at the third thing, that is the door emissions. So here third emissions are the door emissions. See, everything is here, the ovens have the doors, because after all we have to push the coal out or the coke out, so we have to have the door. So no matter how tight we try to make the door, there will always be some leakages. Why there will be leakages? Because all our ovens are under positive pressure. If something is under pressure, some room is under pressure, the air will tend to come out from this wherever they find the leakages. So whole oven, okay, the entire oven or all the ovens in fact will be under positive pressure, and when things have positive pressure they tend to come out, and then there will be the leakages. As you can see, for example, this oven, okay, so these are the doors it has, so it is a constantly there will be some leakages. So there can be some door which is not very tight, there will be more emissions, some door which is very tight, there will be less emissions, but there will always be some emissions. Okay. But also don't forget in the meantime that all the time we are sucking out the emissions that they are taking place. And how we are sucking out? We are sucking out from this duct or from this main. Okay, all the time it is happening, and then it is going to, don't forget, it is going to the byproduct recovery plant where we will recover certain things. Okay, then there's the other emissions, that is number 4, as you see in the picture, they are the top emissions. Okay. So again these holes which are the charging holes, no matter how much tight we try to make them, because these need to be open, as the Larry car will come here, we will open this and the Larry car will charge the coal into it. So these things, no matter how much we try to make this tight, you will still see the emissions which are continuously taking place, and that is called as the top emissions, okay, or the battery top emissions. And battery under fire emissions, as I showed you with this hatch, as you can see here, they are the under fire. Okay, that is a heat that we are producing to heat the coal, and then finally after heating is done, this entire emission, okay, from the heating process goes out from this chimney, and that is my number 5. So you can see the source of emission, but the number 6 emission, which is very important, is when the quenching car takes the coke out and goes all the way in the quenching towers. Huge amount of water is put onto the quenching tower, put onto the coke, and then we have certainly large amount of burning coke kind of thing. We put a lot of water, so there will be a lot of emissions and evaporations that you can see in the form of it is almost like a vapor clouds that you can see. So this will also cause serious air pollution. So what we have done with this one is that we told you about something briefly so far. What is a coke, why we need it, what its purpose is, how it is manufactured, and the main principle is a destructive distillation of the coal that we call as a carbonization. And we also try to show you certain pictures to get a feel how big are the units that we are talking about, and also what are the possible sources of the emission even from a plant which has a byproduct recovery system. Okay, and why these emissions occur? Mostly they are the door leakages, top of the emissions, under fire emissions, pushing emissions, quenching tower emissions, and battery under fire. So you can see these emissions will still take place in spite of the fact that we have a collection system. If we had not had the collection system, things can look very bad. I mean, it will almost be very difficult even to stand anyone even close to the plant. So these are the issues, and then again we will go to the next slide and try to show that, well, pollution are there, but what is so special, what is so important, what is so important that we need to study it separately in a separate lecture and not just do combined with some other lecture. This picture I have already shown you, and now let's go to this one. So let's look at the emissions. Just given you the general emissions, and we'll go to a little bit of the specific emissions. And just to get a little feel, okay, I'll read the sentence here. For every ton of coke produced, approximately 0.7 to 7.4 kilogram of particulate matter. PM stands for particulate matter, which is largely dust. 2.9 kg of SOx. SOx is what? Oxides of sulfur. Huge amount. I mean, I'll give you a little feel, or maybe we can give it right now to give you a little feel as to coke requirement, let's say, so that you know that the quantity of the coke required. It is almost 50% of steel produced, and you know that the steel production steel plants are very huge, very big plants, you know, like a steel plant size is vary actually, but maybe a typical plant which is a little bit on a larger side can be 10 million ton plant. This is a large plant actually, very large plant per year, or annual capacity of 10 million ton. So almost this plant will give a little feel, almost this plant will require coke of about approximately 5 million ton of let's rub it out, 5 million ton of coke per year. See, these are not the small quantities that we are talking about. And then once we are making the coke, what are the emissions that are taking place? 0.7 to 7.4 kilograms of particulate matter, 2.9 kg of oxides of sulfur, 1.4 kg of nitrogen oxides, 0.1 kg of ammonia. Look at that. I mean, you wouldn't expect ammonia, but the ammonia is also emitted. 3 kg of VOCs. You remember VOCs stand for volatile organic compounds, and most of the volatile organic compounds are cancer causing, and it can very adversely affect the human health. So that become very, very important. Including 2 kg of benzene, and you all know the benzene is a carcinogenic compound. You know, the benzene also is emitted from the automobiles, and we all talk about the benzene control. But this in no way this is a small amount, this is a huge amount, and may be released into the atmosphere if there is no vapor recovery system. Vapor recovery system is the same as I was talking about the byproduct recovery plant. If there was no byproduct recovery plant, the emissions could be of this order as specified in this the slide. Apart from this, coal handling operations may account for about 10% of particles load. Coal charging, coke pushing and quenching are a major source of the dust emissions always. So you can see both in terms of the quantity the emissions are large, and also in terms of the toxicity, because some of the compounds that are emitted, they are very serious cancer causing compounds, and we need to control them. Okay, let's go to the next slide. Okay. So the emissions are not only the particulate matter, SOx, ammonia, but there are more things. So now we are trying to get a little bit more specific to the kind of pollution that is taking place. So the benzene I said earlier, but in other quantities, toluene is also emitted from the coke making, so is xylene, and in the common name given to these three compounds are called BTX. So in the rest of our discussions, we will be referring this emission as BTX rather than simply calling it just benzene, okay, or calling it benzene, toluene, xylene. We will simply call this as the BTX. Apart from the other thing, these emissions are also the PAHs, which are nothing but polycyclic aromatic hydrocarbon. These are the again group of compounds, very toxic, proven carcinogens, means it can cause cancer in the human body. So this becomes an important issue. If you don't remember what aromatic hydrocarbons are, so when you have more than 2 benzene rings diffused with each other, that becomes a PAH. So, you can see here there can be many benzene rings as I am drawing them, that can also be combined like this. Okay, that can also be combined like this. Okay, so this is a typical structure, the chemical structure of PHs. Okay, this is just one compound, and you can see you can almost produce, or in fact many of hundreds of PHs are formed, and these PHs are, most of them are carcinogens, which can cause cancer, and therefore we need to control them. So, this is the table, which you can say what we had discussed were the sources of the emission, but we didn't discuss with the particular source what kind of emission that is coming out. So, I made this table so that you can see depending on different source. Okay, as you remember, we talked about 1, 2, 3, 4, 5, 6, and what would come out from those things. Okay, the first source was chimney or under fire, so it will have the combustion related emissions, because here we are burning the things. NOx, that is, you remember what was the NOx? NOx is the summation of NO plus NO2, that is what we call as a NOx. So, you have the NOx, sulfur dioxide, some amount of carbon monoxide, and PM here is particulate matter. Okay, that is the dust. Now, we also remember the door leakages. Simply we can even write here leakage, door leakage, and what emissions will come out? PHs, BTX and H2S. Okay, the dust is not likely to come out, but carcinogenic compounds, serious problem. And we also have the benzene, toluene, xylene and H2S. Why H2S? Because the coal may contain some sulfur, okay, and we are not burning the sulfur, conditions are reduced conditions. So, this sulfur will come out as H2S or hydrogen sulfide gas, and then as a result, maybe it is worthwhile to indicate that the doors which are leaking more H2S comes out, and then as you can see here, the emissions are little yellowish. And you all know the H2S gives a little bit yellowish color. So, okay. So, in fact, sometimes you don't even have to go and see, you can see something yellowish coming out from the coke oven doors, then you can say, ah, look, this is the oven which is leaking, and then once it is leaking, we need to do something about it, because if it was a colorless, you won't be able to see anything, and you won't know what kind of emissions are taking place. But the moment you see yellowish thing coming out, then you are sure that that particular oven is leaking, and the door is leaking. It means the oven is leaking, means the door is not very tightly placed. Okay. Charging hole that we discussed, again charging hole will have the same emission as the PHs, BTX, H2S, that is the time of the leakages that are taking place from the charging hole. Coke pushing that we have seen, again pH, BTX, particulate matter. The new thing coming out here is the particulate matter, because you can imagine something is being dropped from a height. So, there will be dust emission that will come out. So, automatically particulate matter emissions will be there. And the coal charging, as you recall here, when the Larry car, as I said, was moving back and forth, and it is going on the top of the coke ovens, and it was charging the coal into it. So, that again it causes the pH emission, because it is replacing the air which is inside, and also if something is falling down, it means there will be the dust emission will come. Anything you drop from some height, so there will be emissions. So, in what happened in the coke charging, we are really charging or dropping the coal into the coke oven. So, there will be dust emission. So, again you can see here the particulate matter has shown up in the coal charging area. In the quenching, when we are the coke is ready, then we are taking it for the quenching operation. We put the tons of water onto it. So, that is a very high temperature thing is cooled off. So, there will be particulate matter, H2S comes out, little bit of ammonia and some of the alcohols, and it has also been reported that some amount of cyanide in the form of HCN is also either likely to be emitted in the air or will become the part of the water, because we are quenching the coke with the water, and so some of the cyanides also have been reported, some of the pHs and some of the carbon monoxide. So what we have learned here is that in spite of the good recovery system, and what was the recovery system? Through the mains, through the duct in which we are sucking the gases or the volatiles that were being formed, there could still be emissions, and these emissions quantities can be large, and not only large, they can be very serious in terms of their toxic nature. So this issue of the coke ovens become very significant, because it has direct impact and very significant impact onto the public health, and especially to the people who are operating the coke ovens. Remember the person standing with the mask on his face. Let's take our discussion further, and let's talk about some of the controls that we can talk about. So this is what is a little table here, and this table shows here the air emissions, the total air emissions that can take place from the coke manufacturing, and these are the units are here, don't forget, kilogram per ton of the coke produced. So units here, which are also mentioned here. What are the units of kg per ton of coke produced? Okay. Also I must mention here that these emissions, what is being talked about, are the uncontrolled uncontrolled emission. These quantities are not small in any sense, they are really large quantities, and they can influence the air environment. Maybe probably this benzene is you also have benzene here, this benzene is probably in the water, and the source where I have gotten this information is from the World Bank. I should have given you the source actually, World Bank document. Okay, fairly good idea of what is being emitted and what quantities they are likely to emit, and why the importance, because of the associated toxicity. Okay, I want to do an example for you just to give you a feel that these emissions are not small, they are the serious emissions. Okay, the example is the following. Let's examine the emission and impact, both emission and the impact for a 10 million ton steel plant which is producing annually 10 million ton of steel plant. So let's make a little space here. So we'll see emission of, let's say, of a compound. We'll just take one example. Okay, let's take the example of this one, because this is the most dangerous compound in the category of the PAHs. Benzoapyrene is the PAH having 5 benzene rings. Okay, so emission of BAP, in the short we call it BAP. Okay, let's say the uncontrolled emissions. Okay, so for 10 million ton plant, coke that it needs to produce is how much? 50% of the steel that is making. So it should produce coal you need is 50% of the steel that you are making. And how much steel you are making? Tons per year. Okay, so this is my coke requirement, simple thing. Okay, now I want to say my coke, I want to know the coke in terms of tons per day, because I also want to see the impact. So I have 0.5 into 10 into 10 to the power 6, and suppose I am taking, let's say, about 350 days of the working of the plant. So if I take this as the 350, okay, don't forget that these are the, am I doing right or I'm doing wrong? Yeah, I'm doing right. Okay, let's write it properly. Now this is the coke I need in terms of tons per day, not per year, so tons per day. So let's write the spelling correct. Okay. Now you can also tell me the BAP emissions, okay, will be how much? Let's go to the factor here, 0.05 kg per ton of coke produced. So I can say the BAP will be 0.05 times 0.5 times 10 million and divided by 350. So that is what is my BAP. Now you have to tell me the units of this one. What will be the units? Because don't forget the units are kg, kilogram, okay, because this is nothing but kg per ton. So this will be my kg per day, okay, because my factor has units of kg per ton. So much ton was producing, so for every ton 0.05 kg is produced, okay, so this becomes the BAP. So little calculation, you will see that the BAP emissions that comes out to be approximately 750 kg per day, okay, that will be nearly 750 kg per day. Okay, so what we are saying is that the emission of BAP is there's some approximation that I have done here. So let's write it approximately 750 kg per day. This plant, okay, is likely to emit 750 kg per day if it is uncontrolled. Don't forget that what I said here earlier, this is the uncontrolled emission. Okay. Now let's also see what it really means to the people living in that area, because after all, public health, good health of the people is that's what the environmental engineers always try to do. So suppose if I have suppose I assume, I mean it's a simple example or calculation that we are doing. There are more complex, difficult way to do all this. Assume that the entire amount, entire BAP amount is spread into the area or into the volume of, let's say, 5 kilometer by 3 kilometer and height of 1 kilometer. Let's say everything disperses into this, and what it really means in terms of the concentration of BAP that people will be breathing in their lungs. Okay, so that's what we want to find out. Okay, so let's do the concentration part. Okay, the concentration of BAP. Okay, and this is what talking about every day. So almost like 750 kg is emitted. Okay, all right, and how much area, how much volume? Let's write in the meter. 5,000. 5 kilometer equals to 5,000 into 3,000, okay, into 1,000, okay. And then what I can do is kg I can convert into the grams, and this grams I can convert into the micrograms, and the units now I am having is microgram per meter cube. So 1006, so 9 zeros I can remove. Okay, so you have basically, you are left with 750 divided by 15, and then this comes out to be 50 microgram per meter cube. Okay, and you see here this concentration is very, very high. What people are exposed to, this concentration is very, very high. So in fact the standard can be something like 1 nanogram per meter cube. Okay, it means what is the conclusion that we want to see? Pollution of BAP, serious issue, and it needs to be controlled, and to a large extent it is controlled in the byproduct recovery plant. Okay, and but still it is a serious problem. So the efforts have to be made to reduce the emissions. Efforts have to be made to reduce all the emissions, because BAP will be emitted from the door leakages, from the charging, during the charging, charging hose, during the quenching, during the pushing. All things will cause serious emissions of BAP. So we need to control all sources. Just simply saying is not enough that well BAP must be controlled, but then in order for the control, in order for the planning the control, we should know where to control, what are the sources and what are the difficulties. So we will talk about the some of the control systems that is people are using and then one can think of. I think this is a simple calculation. Normally we also should account for the wind, but we have taken a simple example just to give you a little feel, and actual modeling part that we learn a little later in the course, and that will require some more information on the meteorology, the wind direction and other things, but that we won't discuss right now. Okay, now let's talk about the control. See what we have done so far very quickly in half a minute. Let's recap. We have talked about the process, we have talked what is coke, why it is required, what is the process, what are the emissions, what are the emission sources, and within the emission sources what are the important compounds that we need to know, and then we have done a little example to say how much are the quantities that could be released and how much could be the impact. So comes the question, we have concluded that we need to control. So what we do is that, let's see, in the main duct, okay, the problem which we are talking right now is at the time of charging what can be done. So you remember there was a main duct, which was on the, this is a cross section of the battery, okay, and then whatever the, and this is the coke that is being made, okay, and whatever the emissions that are taking place, because this is under positive pressure, they are sucked through this main, okay, and then the main just passes in 3-dimensional if I need to make this one. So what is done is when we are charging something, okay, Larry cart is sitting here and is pushing something, so that is the time we should increase the vacuum, we should increase the suction rate, so that whatever the emissions that are taking place is taken out. So how it is done, suppose at the side of this one I put some steam in there, so it creates the little vacuum here, it will create a little vacuum here, and quickly all these emissions will go through this thing, okay. So that is what we do, is create a vacuum, so that there will be, and once there is a vacuum there will be better delivery of the coal, okay. So you understand, I am sure that by creating more vacuum, we are at the time of charging we are sucking more, okay. What is the, let me remove this so that you can see it clearly. Okay, collection of the emission in the main, two-sided main is better to avoid the formation of heap. See what is happening is that suppose you are charging something, and this is your oven, and then you are charging, as you charge from the Larry cart, it will form the a kind of heap here, okay, and then as you are charging this side also, you will create the little heap here, okay. So what is the new technology that they are saying, that you are taking this thing to the main pipe or main duct, which looked something like this. You should also do it from this side as well, so that from the two sides you are taking out the dirty air and just not from the one side, and that's what is written here, collection of emission in the main, two-sided main, better to avoid the formation of the heap. So that otherwise see heap will be formed. So if you are sucking here, so the heap will not be formed. If you are sucking from this side the air and this side from the air, so the coal will not make a heap, but it will tend to spread out, you know, like this from all over the area, because you are also sucking from this side, so the coal will spread, and then the emissions, whatever the emissions that are taking place, will go to this main also and to this main also. And remember where the emissions are going, emission going to the byproduct recovery plant, okay. So this is what once it can be controlled. The major pollution problem is during the charging, and then we are able to resolve this problem. Emission is treated in the byproduct recovery plant. Once the emission is collected from the byproduct, the main, it goes to the treatment plant. Some of the people are also talking about the leakages. Okay, so Larry hopper should be tight with the charging hole. You know, like as the Larry car is charging, and there's a hole here. Okay, so this must be made tight. Otherwise, what will happen? The leakages will be from here. This is the Larry cart, for example, and this is the oven. Okay, so the fitting should be very tight. And sometimes on the top of the Larry cart, scrubber is provided, okay, to whatever the emissions that are taking place, so that is passed through the scrubber process. After charging, the hole must be luted. Luted means closed seal. You all know the M seal and things like that. So this is called luted. Luted means you put some chemical around this. Mostly it is a clay that is used, so that the charging hole will become airtight. Okay, in quenching towers, what we do is that, as I said to you, in the quenching tower, what is happening is this is here, the cart, okay, with a hot red coke is brought underneath that thing. And what we do here is there is a water tank on top of this, okay, and you open this water tank and the water starts falling down here, because we have to cool down the things, okay. But in this process there are a lot of emissions. So what the people do is they provide some kind of baffle trays. So this dirt, it has to travel this path, and because of the inertia the dirt will fall down. So this is the wet quenching. The latest technology is the dry quenching, extraordinary thing. So you have the cart, okay, and then you use the inert gas like nitrogen, okay, to cool the things. So again here hot coke, and here once I am heating we are cooling it off with the gas, there are no emissions, okay, because emission is taking place because you are putting a lot of water onto it. So and then in this process no emissions. And additionally, the big advantage which the dry system has is the recovery of sensible heat, which is of the great advantage in terms of the production economy. Because the reason is, don't forget, what was the temperature of the coke? Nearly 950 degrees Celsius, and that whole thing we have to cool off. So a lot of heat will be wasted. So rather than wasting the heat by putting the water, we recover the heat by the inert gases, and that inert gas, the heat transfer can take place and the inert gases can be removed. The other problem was the door leakages. As you recall, the door, what happens when the doors are that of, suppose if I show you the section of the coke oven, okay, and then there is a door, which is, this is the coke oven which is going like this, and there is a door okay, and this is the steel jamb, that is what it is called. This door, okay, that is again made of steel, it should go and fit exactly, this should go and fit exactly onto this one. So what is happening because of the high temperature, low temperature, if you look at the sides of the door, it is not simple plane. So when it fits here, so there is always a leakage here, okay, there will be leakage here. So what happens? Door maintenance maintenance. A regular maintenance is required. We have to clean the door, because sometimes straighten them from here. We should make the door straight. See, otherwise, see, you are putting some seal, there will be some leakages from the side which is not perfect. So, we need to stop and then we do the maintenance, and the cleaning of the door is important. What happens is that there will be some particles that get deposited here, and as a result they kind of stop the proper fitting here. So, that the cleaning of the door is required, and finally, once door is fit, there must be seal that needs to be put, seal must be put, okay. Seal must be put, this seal, not seat. Seal must be put all around, and nowadays people are using sodium silicate. Oh yeah, here it goes. Seal of sodium silicate is put, and that almost makes it very good. So, people have been able to control these emissions very effectively. The plant managers, the plant engineers, they are able to control them very effectively, but to make sure that they control it effectively from the production point of view, from health point of view, there are also certain laws and regulations from Government of India that every plant needs to follow and ensure that those laws are enforced and the proper actions are taken. Otherwise, the industry can be in trouble, because the pollution control authorities can close the plant, can put the fine, etc., because this is serious emission issues that we are talking about the coke manufacturing. Okay, so then quickly we talked about the coke making, the sources, the associated toxicity, and we did an example, and we finally showed what are the possible control, and on top of the control there are laws that industry need to follow. And we'll stop